Okay, welcome to Chapter 10. Chapter 10 is all about object-oriented programming. And if you were to pronounce the acronym, it would be OOP. So page 241. Now this is kind of a philosophical chapter. We don't get into too much mechanics. There's more mechanics coming in the next chapter. But Chapter 10 is just introducing you to these high-level concepts. Okay, cool. So there's some terms in here that we're going to use. And I typically attach what I call a catchphrase, something that makes it easy to remember. So I'm going to go through these guys, and then we'll hit them, a little deeper. So the first one is abstraction. So the purpose for abstraction basically is so I don't need to know how the car works to be able to operate a car, right? That's what abstraction is about. So the catchphrase I use is, don't bother me with details. Okay. Encapsulation is I've got things broken up and I've got them bundled together, and so I call this one divide and conquer, which means I've got it broken down into individual pieces and I conquer that one little piece. Inheritance means I don't have to create I want something that's something like a button but has a different attribute, something different. So I don't have to start from scratch. So the catchphrase for that is, don't reinvent the wheel. In other words, once something has already been built, just take that as a starting point and move on. Polymorphism. Polymorphism is the thing where I can program in the general sense and tell it to do something, and the machine is going to say, well, I know you told me to do this, but I'm going to do this instead because this is more appropriate for me. And so the catchphrase for that is, do what's right for you. And then functional decomposition, which is that part of encapsulation where you break things up. Encapsulation, you should break them up and then bundle them. So the breaking up part, which is what we were talking about in the previous chapter on methods. Functional decomposition, I don't really have a catchphrase, but if I had one, it would be something like, making little rocks from big rocks or something goofy like that. Anyway, the idea is that, these are cool little phrases, and you kind of sort of need to know them from a high-level perspective. All right, so on page 242, they talk about, so what is OOP? I mean, is it a style guide? Is it a philosophy? What is it? I mean, how in the world could you even describe it? Well, it is a programming philosophy. It is a methodology. It is a technique. So it's kind of all three of those things thrown together. Now, up to now, you've probably only been doing programs for yourself. And so you've never worked in a team. You've never worked in a corporate environment where they're, cracking the whip to get that game out before Christmas. And so you probably have never experienced the idea of working for someone else who's trying to get code done. So you might look at OOP and go, wow, there's no need for me to do that. That's just a waste of my time. Well, in a corporate environment, it's not a waste of your time. In fact, it's a way to speed things up. Now, is OOP the only answer out there? I mean, is everybody on the OOP bandwagon? Is everybody convinced this is absolutely, positively the best way to go? No. There are all alternatives. Depending on the workload you're trying to do, there's one of the alternatives to OOP is called functional programming. Okay? We're not doing that, but I'm just saying there are alternatives. So, if you got a project that's kind of large, lots and lots of moving parts, so you break it up into manageable chunks, right? Make sense? And the chunks are separate enough from each other so that they can work independently. This is the key. A lot of people say, well, I used encapsulation, it didn't work the way I expected. Well, it's not just encapsulation, you got to do it correctly. Okay? So, to make it work, you have to make it so that these individual chunks do not have side effects. That's not just a feature of OOP, it's something you have to do. Okay. So, let's start from the very beginning. A class. We've got classes. Here's a class for main activity. Okay. So, a class is like a blueprint, or the analogy I like to use is like a recipe. So, if I'm trying to make a batch of chocolate chip cookies, the recipe, which is probably on a piece of paper, right? So, the class is a recipe. and then it produces chocolate chip cookies. So the object is the cookie, right? So the recipe is the piece of paper, and that's the class, and the object, or the instance of the class, is the cookie. Now, it should be fairly obvious that if you try to eat the recipe, it does not taste good, right? So don't do that. A recipe is just a recipe. Eating chocolate chip cookie instances, those are good, but not the recipe. Now, it should be fairly obvious, too, that if I use one recipe to make a dozen cookies, if I pick up one cookie and take a bite out of it, a bite doesn't appear in all the rest of the 11 cookies. That's just dumb. Similarly, if I had a student class and you were one of those instances, when you got an A on a test, does everyone else get an A? No. So those class instances are not really related, are they? Are you related to the other people in your class? Probably not. The only thing you have in common is you both go to the same class, right? That's about it. You're not related in any way. Age, gender, racial origin, right? You're not the same people. Okay, good. So it should be fairly obvious that these things are not really related, these instances. Okay. On page 242, they talk about this, about encapsulation. So encapsulation really has two parts. Before you can encapsulate, you have to do the functional decomposition. You have to break it up. So let's just assume that part's been done. So you've broken things down into manageable chunks, and now it's time to bundle them all together. Now, bundling them all together means that all of the attributes associated with a student, the student ID, and the first name and the last name and your email address and your home address and what your major is and all, what your student standing and maybe even your grade point average, all those things are attributes of you as student. But then, in addition to that, you could have actions that could happen to you. An action would be you register for a class, or you take a quiz, or you receive a grade. Okay? So some things are relatively static unless you change your name. Probably most of the things I talked about at the beginning aren't going to change. Your name and your ID and your address. I mean, they can change, but not very often. But getting a quiz result, yeah, that's going to happen a lot, right? And that's going to change quite a few times as you as a student. Okay, so there's the nouns are name, address, those kind of things. Those are nouns, right? They change, but not very often. And then there's actions that you can do, like register or receive quiz grade, that kind of stuff. Those are actions that occur. All right. So if you bundle those things together, both the static things, the nouns, and the actions together, that's what encapsulation is all about. And it makes it easy because if I move a student from one, like you go to the finance office or you go to the place that does the scholarships, or if you go over to the registrar's office, you just follow along. Your class instance just moves along between each one of these stages, so to speak. And so I don't ever have to say, well, who's got the dang email address? Because it sticks with you. It goes with you wherever you are. That's what encapsulation is all about. Okay, if done correctly, then the things that happen to you as a student do not have a side effect on other things. Okay, so when you receive a quiz score or when you register for a class, it's not going to have a negative side effect someplace. It's not going to crash something in the finance office. Or if somebody in the finance office did something, it's not going to crash you over here at the registrar's office. That's what it's all about. Is if you have them bundled together and you've done it correctly, then there'll be no side effects. Well, let me put that back. No bad side effects. And so it should not depend on other classes. There really shouldn't be a tight coupling between this class and some other class, because that means if I make changes to one, it might break the other. That's the whole point. Okay, so if you do this right, this could make it pretty doggone easy for code reuse. And code reuse is the holy grail of productivity from a corporate point of view. I mean, if you're producing a game and you're a professional programmer working for, Epic Games, well, then they really are interested in performance. right? And they don't really want you to be writing a new character class from scratch because they already have a character class and they want to be able to just reuse the character class over again. This is a warrior character and here's his health and here's his weapons and here's how many pounds of stuff he's carrying, you know, all these attributes. Somebody's already got that worked out. Okay? So it's a real productivity booster if done correctly. Inheritance on page 243. So I can use other people's code without too much effort. If somebody has a weapon, and it's a ranged weapon, quote unquote, and I want to build a special ranged weapon, I don't know, with more capabilities. Well then, in what I'm working on this game, I just start with a ranged weapon, and then I add to that thing my specialty that I want. I don't know, it's got a better scope on the rifle or a larger magazine for holding more ammo, whatever the game requires. So I start with something, and I don't have to write the whole weapon over from scratch. All I have to do is just tweak it a little bit. So that's what inheritance is all about. In the example of a button, you know, we've done buttons in this before, but what if I wanted a special button? I wanted a button so that when you clicked on the button, I don't know, something goofy like the text that's in there does a rotate when you click on it. Something goofy like that. Well, I mean, you could just start from scratch and say, well, let me just write my own button. That would be one heck of a lot of work, and your boss would be very, very pissed that you spent all that time working on it when you could have just inherited from the button class and then changed the it's called paint. Change the paint routine to have an object rotate inside it. Okay? So that's what the inheritance is all about. Again, inheritance is all about making things run faster and making your boss happy because you're not wasting time. All right, now, you have probably seen that we use the extends keyword to do inheritance. So our main activity is inheriting from app compat activity. Okay, good. So you know that. There's some other terms associated with this that you might come across. One is a base class or a super class, okay? And then a subclass, okay? So an object can be inheriting, you know, from something and then it could be something else. Let me show you an example here of, whoa, that's not what I want. Here we go. So here's an employee class that, and so I wanted a thing called a non-exempt employee. Don't worry about what that is. It's not really important at this point. But I inherited from employee, and all I had to do was just tweak it to do whatever the heck that thing is. And then I needed another type of employee called a com plus employee. Again, don't worry about what that means right this very second. And I inherited from the employee non-exempt. So there's a chain of inheritance here, okay? So it's perfectly normal to have something inherit from something, to have it inherit and have it inherit and inherit. Now, oddly enough, in the Java language, everything, well, let me rephrase that, all reference types inherit from a special class called object. And I'm object with a capital O, because sometimes we use the word object to mean an instance. It's confusing. Just take a deep breath. Object with a little o means an instance. Object with a big O means this class. Okay. Hey, come on. All right. So is this considered multiple inheritance? No, it's not multiple inheritance. This is just a chain of inheritance. So this is a superclass for that guy, and this guy has a superclass, and it's that guy. Hey, is it easy for me to go from here to gather some information way back up here? Not really. It's kind of difficult to do. Okay, we're coming up on the 15-minute mark. You guys know how this works.